Hi Jessica, it's me again. Alright, so here's question 2, or my best shot at it. I'm not a stats major, so I want to make sure that we're doing these right. So what I've done is I put together a couple of different things here to help us sort of understand how to choose the appropriate test under different conditions. So it might help if we look at that first. Here's the first one that I put together, and this has to do with all the different tests that are mentioned here. And so the dependent t-test, it's for two related groups to see if there's a statistically significant difference between the means. So the related groups could be something like in the example of I think it was the NHL team, where it's the preseason and postseason weights. And so that's the same group being tested both times, but something has changed in that group, which is they've played a season of hockey, and so now they're testing their weights. So that would be one example of it, and they give some other examples here. Sorry, no, those examples are categorical variables, okay? Moving on then to, the independent t-test. Okay. So if it's independent, you are looking at two independent groups that have no relation to each other, and you're testing to see if there's a significant difference between those two groups. Now, if you have a z-test, it says here like two normally distributed but independent populations. So we're looking for two independent populations. Something else about the z-test, that's the wrong one, sorry, about the z-test, is that you're comparing the means of two different groups to see if there's a statistical difference between those two groups. And it's usually as a result of something that you're testing, because it's usually a hypothesis test with the z that you're doing. And so you're testing to see if there's a significant difference between two groups. You know, if something happened, like say a drug test or something, if you had a control group and you had a group that was being tested on a new medication, and then at the end of the experiment you would compare, you know, maybe the death rate between the two groups or something, then that would be a z-test of two independent samples, and you would be looking for whether or not there was a significant statistical difference between those two groups, so that you could make a conclusion as to whether or not the drug was helpful or not in treating that particular disease. So I hope that makes sense. The other thing, sorry to be talking so much, but the other piece of information that I have for you here is just in terms of breaking down your t-tests and trying to determine whether you have an independent or a dependent t-test. This breaks that down a little bit for you. You have two independent proportions when you have categorical data. So if you're just measuring like a yes or no answer, or you know, something does or something doesn't, or something like that, then those are two independent proportions. And so we'll talk about that a little bit more in terms of determining which thing is which when we go through your list for question 2. If the measurements are quantitative, so that means like a quantity or a number that you can put on things, and taken from two distinctive groups, then that's going to be an analysis comparing two independent means. So you see the difference here is proportions, and this is means. If the measurements are quantitative, so the same as the previous one, quantitative, so it would be like a weight or a grade or something, and they're taken twice from each subject. So that would be like your NHL players. You're taking their weight at the beginning and the end of the season. Then you are going going to be comparing to dependent means, because that's coming from, those two measurements are coming from the same people each time. And then we have dependent proportions. So an example of that is asking subjects whether they support a particular candidate before and after a debate. So their choice might depend on the performance on the debate. And so we won't get into that, but I thought I would give you that information to help with the questions. So if we go back to your questions and we use all of this information to try to analyze the questions that they're asking here in each of these examples. So let's look at the first one. It's a comparison of the mean of recycling participation between 9 large cities and 11 small cities. So we're comparing means, not proportions, but these two populations are independent, and this is categorical, right? Because it's just, do you recycle or don't you? And so in that case, from two distinct groups and categorical data, we would be looking at two independent, proportions. We want means here, so independent means. I guess it's independent proportions, so we would be looking at an independent t-test for the first one. For the second one, we've got the comparison of weights from the hockey team at the beginning versus the end of the NHL season. So again, if we look at our definitions here, this time we're looking at the comparison of groups. We're looking at taking it twice from each subject, and so it fits into here. And so we're comparing to dependent means, so we would be looking at a dependent t-test for the hockey players. If we have the comparison of the fin lengths of 35 male and 37 female brook trout sampled in the lake, then in that case, I would say that that's quantitative. It's taken from two distinct groups, so I would say that those are two independent samples that we're dealing with, and I would use an independent t-test on that one. For number 4, we have the comparison of the mass of 100 grain-fed calves versus 100 grazing calves. So for that one, what I would choose would be the Z test, because you're comparing two samples, and there's a difference between the feed for these two calves. So we're probably setting up a hypothesis test here where we're trying to determine whether or not the type of feed is resulting in a change in mass for these groups of cows. So they're independent. We have two samples, but this would fit into a hypothesis test situation, and that's what makes this a Z test. And then for the last one, we have a comparison of body weights of, I think it says 10 male and 23 female students from grade 9 at Adam Scott. And so again, we have two independent groups here. We're doing a quantitative measurement, so we have two independent means. So we would look at I think we would be looking here at, I would say an independent t-test, because we have two independent samples. We could also make a case, I suppose, for this one to be a hypothesis test. If you were going to say that, gender affected weight, and you wanted to know if there was a significant difference between the weights of males versus females, you could make it into a hypothesis test, and then in that case it would be the two-sample Z test. It's an interesting one. I hadn't sort of thought of that. At first I would have thought of the t-test for independent for that one. I'm not sure. I'll leave that one up to you, I guess, to decide. I'm leaning towards the t-test for independent there because there's nothing that they've introduced in terms of a difference, if you were comparing the body weights of a group of male students who worked out and then a group who didn't, and so you're identifying, one particular factor. But again, gender is also a factor, so that one's a tough one. I'm not sure exactly what to tell you for that one. I'm sorry. So I hope that helps anyway, and I hope that that information is helpful in helping you narrow that down for future questions.